Hello everyone. Today we're going to talk about one sample t-test and on how to solve this using SPSS. One sample t-test is used to test whether the sample mean of one set of measurements taken on a single population is different from an expected value. The one sample t-test calculates how many standard errors the sample mean is away from the expected value. This could be computed using the formula P equals sample mean minus expected mean divided by the standard error of the mean. The standard error of the mean can be computed by dividing the standard deviation by the square root of the n or number of samples. In one sample t-test, the farther away the mean is from the expected value, the larger the value of t, and the less probable it is that the real population mean could be the expected value. Here we have the body lengths of 18 samples of a certain fish species taken from a big box having 4.3 centimeters as expected mean length. The researcher wanted to find out if the lengths of the 18 samples differ from the expected mean, which is 4.3 centimeters. To solve the problem, we start by formulating the null hypothesis. In this case, our null hypothesis is the mean length of the 18 fish samples is not different from the expected mean length, which is 4.3 centimeters. To solve the problem, the second step is to carry out a one sample t-test. We need to enter all the data into a single column and give the column a name, fish length. To run the test, click on the Analyze menu, then move on to the Compare Means and click on One Sample t-test. Use the arrow to put the fish length into the test variables. Encode in the test value the expected mean, which is 4.3, which we wish to compare with the sample mean. Then, click OK to run the analysis. SPSS will produce the descriptive statistics as shown in the top table. Here we have 18 as the number of samples. The sample mean is 4.68 centimeters. And we have here the standard deviation as well as the standard error of the mean. In the second table, we have the computed t, which is 7.47, and the probability value, which is 0.000. The third step is to compare the probability value with the 5% level of significance. In this case, the probability value, which is 0.000, is lesser than 0.05. This would lead us to come up with a decision. Because the probability value is lesser than 0.05, we must reject the null hypothesis. This means that the sample mean, which is 4.68 centimeters, is significantly different from the expected mean, which is 4.3 centimeters. The last step is to interpret the confidence limits. The 95% confidence interval of the difference is given in the second table as between 0.28 and 0.49. This means that the sample mean are 95% likely to be between 0.28 and 0.49 centimeters longer than 4.3 centimeters. That's all for now. I shall post another tutorial on how to solve this problem using a calculator, so please don't forget to subscribe to keep you updated of our tutorials. Thank you very much.